In this lesson, we're going to explore multiplication and how to relate it to expanding brackets. Okay, so before we have any proper discussion about multiplication, I'm going to start by just multiplying two numbers. I'm going to choose to multiply 23 and 17. Now most people, when they are told to multiply two numbers, would just think, well, let's take out a calculator and type them in. But when you were younger, for some reason, they decided to show you some algorithm that you could follow to figure out the answer if you didn't have a calculator around. I'm sorry if this technique here brings back bad memories for any of you. I mean, surely any sane person who wanted to multiply two numbers like this would just take out a calculator or use their phone. I mean, every phone has a calculator these days. But instead, when you were younger, they decided to teach you this. Now, despite the fact that you can use a calculator to find out what 23 times 17 is, there's actually a deeper reason for showing you this actual method over here. But before you can understand that deeper reason, let's just actually try to go through this one together and see how it works. The first thing you were told to do is to multiply this 7 and this 3, and that gives you 21. Now, in a little bit of a weird twist, rather than putting the 2 here, you're supposed to put it up here. After you've done this, you're supposed to multiply this 7 by this 2, which will give you 14, and then you're supposed to add that 2 from before, which gives you 16. Then in the next step, you're supposed to put a 0 over here, so let me do that too. Then after this, you go ahead and multiply 1 and 3, and then you put the answer over here, which is just 3. And then after this, you're supposed to multiply the 1 and the 2, and you put the answer over here, which is just 2. And then, in a real twist, you're told that you're supposed to actually add this number to this number over here. And then you just start to think, but I thought we were multiplying. Now, I'm assuming you remember roughly how to add 3-digit numbers, but you just add this 1 and the 0, which gives you a 1 here, add the 6 and 3, which gives you a 9, and then add the 1 and 2, which gives you a 3, and then you just write down all of those digits. And even while I'm recording this, there's a young version of me that's asking all these questions. I mean, what's the deal with carrying this number over here? Why are we adding? Why are we putting a 0 here? I mean, there's so many questions that I wanted to ask, and I really never got a good answer to them. Now, we call this sort of thing over here an algorithm, and indeed, it's exactly what a calculator would be doing under the hood whenever you type something into it. But then I guess the real question is, why am I teaching you this algorithm? How are you going to benefit by actually knowing how to multiply these numbers if you can always use your phone to do it? Well, to be honest with you, the main reason you learn how to multiply by hand is so that you can have a deep understanding of how multiplication actually works. However, I'm not really a big fan of this method over here. So instead, what I'm going to do is I'm going to multiply 23 and 17 in a slightly different way. A little bit of a simpler way, but a different way nevertheless. I think for most people, when they were introduced to multiplication, they were told that 23 times 17 is the same thing as 23 groups of 17 of anything you like. So I'm going to start by drawing on a block, and then we're going to try to figure out how many blocks we'd have if we multiply 23 by 17. Okay, so now we have one block, but we said that we wanted 23 times 17 of them. So I'm going to start by actually copying this block over 23 times in a single row. Okay, and now that we have 23 bricks in a single row, we're going to need 17 rows to get the total number of bricks. So now if you look carefully, we have 17 rows of 23 bricks. This should equal the 391 that we got before. Now, one completely legitimate way to actually work out how many bricks you have is to sit down and count them one by one. But of course I wouldn't really recommend that. Now, of course, you could make this a little bit faster if you got some other people to help you. You could cut this large shape up into a number of different parts, and then you could get one person to count this part, another to count this part, another to get this one, and then another to count this one. Once you've counted those 4 parts, you can then combine your totals by just adding them. Now, hidden in this thought is a really smart way to actually count the total number of bricks. In order to show this to you, I'm going to get rid of the grass, and then I'm going to cut it up into 4 sections that I've chosen very carefully. Okay, so what I did here was that I broke 23 up into 20 plus 3, so I broke it up into its tens and ones. I then also did the same thing for 17. I broke it up into 10 plus 7. Now of course, the reason I broke things up in this particular way is because we can multiply 3 by 7 really easily. we can also multiply 3 by 10 really easily, and the same goes for these two squares as well. So we know that 3 groups of 7 is just 21, so let me write that down. And now 10 groups of 3 is the same thing as 30. Okay, next in this block over here, there's actually 7 groups of 20, and we know that 7 times 2 is 14, so 7 times 20 is going to be 140. Now onto the last block over here. We know that we want 20 groups of 10, and we know that 20 times 10 is just going to be 200, because 2 times 1 is 2, and then you add on the 2 zeros. Okay, and now the final thing we would do is we would just add all of these numbers up, right? But if you look carefully at the numbers, I hope you can see something pretty interesting. What is 200 plus 30? Well, that's the same thing as 230. And then what's 140 plus 21? Well, that's the same thing as 161. Okay, so instead of just multiplying 23 and 17 to get your final answer, you can instead multiply all of these pairs, and this will give you 4 blocks that you can just go ahead and add. Now, if you properly understood this, then you can answer most of the questions you had about this original technique. The reason we put a 0 here, for example, is because we're multiplying by 10 and not by 1. The reason we follow a pattern that looks like this is because we're multiplying each individual rectangle, 1 by 1. Now, this technique over here is so general that you can actually use it to multiply any 2 numbers you like. You can always just draw up this rectangle here, and you can multiply them, and that will be the exact same thing as doing this. Okay, so now that we know how to multiply 2 numbers like this, what happens if we actually don't know the values of 2 of the numbers? Let's suppose that there were pronumerals, which I'm going to name x and y. So for example, I want you to imagine that we're going to expand x plus 3 and y plus 7. I've changed the picture over here because we're going to use it to help us do this. Okay, so for most students around the world, they get taught to do this by using the FOIL or rainbow method. The way this works is you're supposed to multiply the x by the y and then the x by the 7. Then you multiply the 3 by the y and then the 3 by the 7. Now to be clear, I use this method as well. This is how I multiply most of the time. But it begs a few questions like, why exactly are we drawing this rainbow over here? What's the deal with it? Well, now we should turn our attention back at this rectangle over here. I want you to notice that this over here is x and this is 3. So this over here is x plus 3. And then this over here is y and this is 7. So that means this whole height over here is just y plus 7. Okay, now x can represent any number you want, and y can represent any number you want. But why should this be any different to the square multiplication technique that I showed you for this example over here? It's not. We're going to use the exact same technique. We know that 7 times 3 is still 21, so we have this 21 over here. But then this unknown height y and 3 multiply together to give you 3 times whatever y is going to be. So that's just 3y. Okay, so next we turn our attention to this block over here. We know that in this block, there are 7 groups of x blocks, so there are going to be 7x blocks. And now if we look carefully, this 3y just shows up over here, and this 7x just shows up over here. And now for the final block, this one over here. We know we have x groups of y blocks. It's a little bit confusing when you say it like that, but this is really just the same thing as x times y. And of course, this xy just shows up over here. So as you can see, this rainbow method that we have here is just a helpful mnemonic to help us remember to do this. So it's perfectly okay to just memorize this rainbow over here. But I'd say that you aren't actually really understanding anything if you're just memorizing a technique like this. It's always important to remember that the rainbow is actually just a shorthand for this over here. In fact, even when we applied this directly to numbers, I want you to realize that we rewrote 23 as 20 plus 3, and 17 was 10 plus 7. We said that 23 times 17 is the exact same thing as this whole expression on the right. And here I'm just saying that it's the exact same thing as 20 plus 3 times 10 plus 7. So once I've written it in this form over here, I'm going to go ahead and apply the rainbow method again. So if we applied this exact same rainbow method here, we can see that 20 times 10 shows up here, 20 times 7 shows up here, 3 times 10 shows up here, and then 3 times 7 just shows up here. So these two methods are completely identical. So I hope you can see that this technique you were taught potentially as a kid is the exact same thing as this technique over here. And this is the exact same thing as this FOIL method or this rainbow method that you probably got taught sometime later. It's really cool to see that this and this are actually connected in such an intimate way. But of course, there's a big reason why I like to show this way over here. It gives you insight, and you can use insight to actually solve much harder examples than these simple ones we've given over here. Now, to show you how we can easily generalize this idea, let me show you a much harder example, and let's expand it together. In the original example, we expanded things that only had 2 terms per bracket. In this case, we actually have 3 terms in each bracket, so the expansion is actually going to be a fair bit harder. Now, it is possible to generalize the rainbow method, but instead I'm going to use a box to do this. Let me go ahead and draw a box where one of the sides is x squared plus 3x plus 4, and the other side is x squared plus 7x plus 2. Now, I haven't actually written in the plus signs on purpose, because as we did before, we want to go ahead and cut this up into 3 different sections on each of the sides. Okay, so without doing too much work, we can immediately see that there are going to be 9 possible values that we need to expand. Another thing you'll notice is that I haven't been really careful with the size of this box, or the size of any of the grids. The idea is that this is not meant to be a 2-scale representation of the technique that we used before. It's just meant to be a useful tool that I can use to actually help me solve this problem. Now, if you think about it, we don't really know the value of x, so we can't even draw this to scale even if we wanted to, because we don't know how large to make these different boxes. But that doesn't make the picture any less useful to help us actually solve this particular problem. Okay, so for starters, I want to figure out how many blocks fit in this square over here. We know that there are 4 on this side and 2 on this side, so that means we're going to fit 8 over here. Next, I turn my attention to this block over here. I notice that on this side there are going to be 4 blocks, but on this side over here there are 7 times x blocks. 7 times 4 is 28, and then you just have to multiply this by whatever x is going to be. Then we turn our attention to this block at the top. This side is just 4 again, but this side over here is x squared, so we just have to multiply 4 and x squared. Now we just continue this for the rest of the box. This one over here has 2 on this side and 3x on this side. 2 times 3 is 6, and then you multiply that by x, so you get 6x. For this one over here, we have 3x on this side and 7x on this side. 3 times 7 is 21, but then you've got x times x. X times x is just going to be x squared, because anything times anything is the same thing as that thing squared. So just to be clear about this, for example, we'd say 7 times 7 is the same thing as 7 squared. That's just a shorthand way to write this. After this, we're just going to figure out this square over here. And this is going to be x squared on this side and 3x on this side. So we're going to get 3 times x squared. Now x times x squared is going to be x cubed. An easy way to see this is to just put numbers to it, which is what you should always do whenever you're in doubt about something. So for example, we could say that 7 squared times 7 is going to be the same thing as 7 cubed. We can see that because 7 squared is 7 times 7, and then you just multiply this 7 on. Then after this, we can see that 7 times 7 times 7 is just the same thing as 7 cubed. So 7 squared times 7 is 7 cubed, and therefore x squared times x is just going to be x cubed. Okay, so by now I hope you've got the gist of things, so I'm going to fill in these 3 really quickly. This one over here is just going to be 2x squared. This one over here is going to be 7x cubed. And then this one over here is just going to be x squared times x squared, which is x to the power of 4. Now, just like we did before, we can go ahead and add up all of these individual squares to get the total area. But instead of doing this, I'm actually going to show you an even bigger simplification. And I'm going to do this by color coding all of the different squares. So I've color coded all of the diagonals, as you can see. All of the diagonals have the exact same color. The reason I've done that is because I hope you can see that the units are over here. The values that have exactly 1x are colored in this color, and then these colors over here represent all the x squared values. Now this is going to give us a really quick way to add up all of these values. This value over here is equal to 8, so let's just copy that. After this, we want to add 28x and 6x. This is going to be the exact same thing as 34x, so we can copy that down too. Now we want to add up all of the terms that have an x squared in them. This is just 2 plus 4, which is 6, plus 21x squared, which is the same thing as 27x squared. Now for the x cubed terms, we just add 7 and 3, which is the same thing as 10x cubed. And finally, we just add on this x to the power of 4, which completes our answer. And this is really cool. This tells us that if we expanded x squared plus 3x plus 4 all times x squared plus 7x plus 2, we just get x to the power of 4 plus 10 groups of x cubed, 27 groups of x squared, 34 groups of x, and then the number 8 left over. If you wanted to make this even faster for yourself, you could just leave off all the powers of x, as long as you remember that the diagonals increase by 1 power at a time. After this, the whole thing just turns into an adding game. For example, 28 plus 6 is just going to give you this number 34. 2 plus 21 plus 4, well, that's just going to be the same thing as this 27. Now, there's nothing special about this particular example that I've given you over here. You could really have anything you wanted, and as long as you drew the correct square and multiplied the terms properly, you should be able to expand it. So I think the best way to get used to this is to just do as much practice as you can to figure out exactly what to do in any given situation. So now I'd just like to summarize this lesson. At the beginning of this lesson, we talked about this old technique that you probably learned to multiply. I told you that I didn't really understand it very much when I was little, but then as I grew older, I started to see why it was important. We found out that we could actually perform this multiplication by using a large rectangle like this, and this allowed us to actually see that 23 times 17 is the exact same thing as all of this. In essence, we're just rewriting 23 as 20 plus 3 and 17 as 10 plus 7, and then we use this rainbow method to expand out all of the individual terms. Now, I hope you can see that the reason we even bothered to show you this is so that we can generalize it to situations where you may not have all of the individual numbers. By replacing the 20 and the 10 for an x and a y, we notice that the exact same technique can be used for this problem over here, and then we can expand brackets like these to give you something like this. We said that you could always use this FOIL or rainbow method to expand brackets, but this method over here can be generalized to deal with much more complicated situations than FOIL can handle. I even showed you a much harder example, and we worked through it together. However, throughout this lesson, I did steer away from one thing very carefully. I made sure that none of the numbers I gave you were negative numbers. Not a single one of them is negative. In the future, we're going to talk about how negative numbers affect this technique over here. We're going to generalize it to figure out how to deal with situations where you may have negatives instead of positives in the brackets. But I think this is actually a really good point to end the lesson. So I'm going to say that this concludes our introduction to the rules of multiplication. Thanks for watching another Trina video. If you want to say thanks, you got to show your friends. Or maybe you should just visit us at trina.org, where you can track your progress and have access to questions and heaps of other awesome stuff. Or maybe you should just like and subscribe. That works too. But either way, I'll see you next time.